In section 8.1, we're going to describe the formation of covalent bonds in terms of atomic overlap, and we're going to define and give examples of sigma and pi bonds. So, Linus Pauling and others developed the Valence Bond Theory of covalent bonding. Linus Pauling won his Nobel Prize for his theories on crystallography and bonding. He wrote the book, The Nature of the Chemical Bond, which for a long time was the book on the subject. He said that electrons reside in orbitals. Covalent bonds form when electrons are shared by the overlapping of singly occupied orbitals. Electrons in these overlapping orbitals must have opposite spins. So if you think about the formation of a bond in H2, if this is the distance between the two nuclei, at some optimal point, the energy will be at its lowest, and this will be the bond distance that it wants to have. If you push them any closer and lower that bond distance, the two nuclei are going to repel each other, and the energy is going to spike up really high. If you start to pull them any further away from each other, then you're going to be inputting energy to break that bond, and the energy is going to go higher and higher until you reach the bond breaking point. The distance between this center line of zero energy and this optimal point right here is going to be the dissociation energy for that bond. To form a covalent bond, an atom must have an unpaired electron. The number of bonds formed by an atom is determined by the number of unpaired electrons. This theory works well for explaining the bonding in diatomic molecules with only single bonds. This theory also works well for explaining the lack of bonding experienced by noble gases. Here we can see the overlap of two p orbitals in a direct end-to-end connection. And if you tip them in any one way, if you orient them in any other way, you're going to see less orbital overlap. So this is going to be our preferred configuration. And when bonding happens like that, we call it a sigma bond. This is a covalent bond in which the electron density is concentrated in the region along the internuclear axis. All sigma bonds all single bonds are sigma bonds. So that starts off by forming these sigma bonds. After that, double bonds and triple bonds are what they call pi bonds. This is a type of covalent bond that results from the side-by-side overlap of two p orbitals. So multiple bonds are mixtures of sigma and pi bonds. Here we can picture some sigma bonds from two s orbitals. Here's an s orbital with a p orbital, and here is it with two p orbitals. Pi bonds occur when we have the other two p orbitals, because remember those are at 90 degrees from each other, and they have a side-by-side interaction. So you're going to have this one, and then if you imagine this turned 90 degrees along the internuclear axis, there could be another interaction leading to a triple bond. So remember, we always begin with sigma bonds. So in a single bonded system like this, we have one sigma bond and no pi bonds. When we do a double bond, we have one sigma bond and one pi bond. And then a triple bond is a sigma bond with two pi bonds.